very good morning. Welcome to the QuaNTA NXT series. As you know, we are the web conference for quality engineering, premier quality engineering, and automation series. Till now, let's say for past couple of years, we have actually been holding this QuaNTA NXT as an in-house event where we invited all the talented engineers in the office. But unfortunately, due to the COVID situation this time, we are inaugurating QuaNTA NXT as a web conference series. And as a part of that web conference series, today we will be starting with our first topic, which is machine learning in new age of automation testing. However, let me just go ahead and introduce myself first, which I kind of forgot. But hi, everyone. I am Anaga Pawar. I am heading the quality engineering practice at Globant India. And with me is Shivraj Sable, who is the Globant India head. And he'll be giving us a brief walkthrough for Globant. And once that is over, we'll go ahead and get started with the topic for today. So Shivraj, to you.
Thank you, Anaga. Hey, folks, very good morning. I assume all of you can hear this. Nina, do we want to do a quick audio check for everyone?
Yeah, everybody can hear you.
Excellent. Great. All right, so let's go ahead with this. Folks, I'm not going to take a lot of time. I think there is an amazing talk coming up by Gaurav, one of our very old trusted friends in this industry. And Gaurav actually brings in amazing talk around the latest that is there with automation. So I'm not going to take away a lot of time from that. I just want to set a tone of why this conference is going to be super important for all of you going forward. Why is it even important to spend time on a weekend in the morning instead of having a nice sleep and coming here to actually attend a conference? What is very important to understand in this era of COVID also is how the industry is changing. One of the major questions that comes up these days is, how is the industry changing? What is happening? Are we losing jobs? Where do we see the IT industry in the next few years? There's a lot of questions that are left unanswered because of the uncertainty in the industry. But over the years, one thing we've learned is this uncertainty is because we are not defining our own path ahead. So if you are in fact defining your own path ahead, if you're defining how the world works, there is no uncertainty in that. The world has to work regardless of COVID, not COVID. The world engine is going to keep on going. It may be slower, but the engine will keep on going. So if you're at the helm of defining of how the world works, the engine is never going to stop for you. So that is the key. The key is to now understand where the world is moving, what is happening with the industry, and then we move on to very quickly the topics today. All right. So a couple of questions which I really quickly get started with generally most of the times is to understand this industry change, a few questions which I've been putting across for a long time now. And then a lot of times you still see those questions. I'm not going to wait for answers from you, but I'll probably answer them myself. So, for example, which do you think or rather, when was the last time any of you ever visited a bank branch, right? What is your recollection of going to a bank branch for doing something? More often than not, we do it from our phones, we do it from laptops, we don't go to the bank branches. And then there are banks who've invested lots of money in these premier banks, branches all over Pune and Mumbai, and they don't know what to do with it. Business has changed. When you say which is the topmost cab company in the world, the name that comes across is Uber. When you think which is the largest online retail company in the world, the name that comes across is Amazon, Alibaba, or the likes of it. Now, if you twist the question a bit, do you feel Uber is a cab company, or is it actually a software platform company, right? Do you feel Amazon is a retail company, or is it actually a software platform company? So if you see both of these are pure software platform companies, they have created softwares and they have nothing to do with the domain itself. So what has happened is the business has changed for them. The people who are now doing business in that domain are different and not the same ones. Another example, which is very, very amazing, was in 2012. I think I had asked it in the last series too. Which company sold the highest amount of music in 2012 in India? Well, possible answers are T-Series, Sony. The company that sold the highest amount of music in 2012 was Airtel. And you would guess why Airtel? Because they had that kind of reach with the customer base, and they were selling those ₹1 songs. Now imagine you were a mobile developer or a mobile tester or a mobile automation engineer on that app, on the Airtel app when this was happening. What do you think makes sense to be the landing page for this app? Do you think it's the bill plan? Do you feel it is the Airtel logo? Or do you feel that as a developer, as a tester, you should be busy working on the best music player in the industry? See how the industry has changed, see how the game has changed, very, very importantly, and how the business has changed. So if you have to survive this COVID situation, if you have to survive situations which are up and down in terms of the whole industry, what is very, very important is this ability to understand this business change, ability to translate this business change into your work, and the opposite. For example, what impact does a single line of code that you check in, what impact does a single test case that you write, be it automated or manual, that makes, what is the impact that it's making on the end consumer and the end business is very, very important. If you're able to translate every single thing that you do into a business impact, that is where you start looking at the bigger picture. That is where you start looking at the business impact. This happens when you understand what the business has changed. So now if you look at it, honestly speaking, the domains, the domain knowledge is out of the window. It's good to have some domain knowledge. What matters is what can you impact the domain, because that domain itself has really completely changed. One of the good examples is a banking project. We have created a first end-to-end digital bank for the world, along with Santander, which is one of the largest conglomerates in Europe. And this was without a single person having banking experience. Remember, this was a request by Santander saying, don't give us anyone who has prior banking experience, because they're going to come up with the same experience, same knowledge. So remember now, more than domain, what is important is the ability to create solutions. When you do this, because the game has changed, and when you change your skills, the ability to create end-to-end solutions, ability to translate every single thing you do into a business impact, is when you start staying relevant, is when you'll never lose your job regardless of the situation. All right, a very quick I'll quickly take you through this conundrum. You see two major pictures on the side. I won't have any prizes for guessing who's on the left. The great Gavaskar, and you see obviously the youngsters on the right. Not so much with Dhoni, but still. Now, the question today is, would Gavaskar get selected into the team today? If he were to be selected for the team, would he get selected? Well, the answer is no, because the game has changed. Earlier, it used to be 5 days, 7 days. Now it has come to 4 hours. And what is required to be successful has completely changed. What you see on the right is the yo-yo test. Most of you already probably know it. It's quickly running between 2 points within a certain amount of time. And if you're not able to do that, you don't even qualify to show your cricketing skills, because you have to first pass the physical test. And that's where you might have famously seen Yuvraj dropping out of the team because he could not pass the yo-yo test. So the game has changed, and your skills required to be successful in this new world has changed. So it is very important for you to understand this, understand what is the business change, understand what it takes to be successful in this world, right? So that is what is very important. That is why it is very important to be part of these conferences. Pay attention to what Gaurav is going to say today. It is very, very important to ask a lot of questions, very important to dwell deeper into this, go back home, and then well, everyone is at home already, but go back to your drawing rooms and then see what are the things that you want to focus on. Read about the things that you hear about today, and then dwell deeper. Some of these skills are going to make you relevant and going to be very, very important for you. All right. So very quickly, the best way, like I said, to predict the future, because nobody's aware, is to create it. So be part of this change. we as part of Globant are the forefront of being able to provide digital transformations and the ability to transform companies have traditionally done business in a very traditional way, have gone to very traditional vendors for creating software, creating some fancy apps, fancy web apps. But then the key is the ability to actually digitally transform yourself, disrupt yourself to an extent where nobody else will be able to disrupt you, right? So why is it so important? If you look at the 2018 to 2023 trend, the share of digital transformations in trillions is this. So basically, by 2023, $53.3 trillion industry would be digitally transformed. And this is pre-COVID. Now, post-COVID, this has already gone up to $75 trillion. And that is the key. That is the kind of market share that companies are looking for when it is digital transformation. So if you are working in a company which is truly causing digital transformation, even if not, if you are on a project which is causing digital transformation, that's what matters. Like I said, always think of what is the impact that you're causing to the end customer. That is very, very important. All right. So focus on this. This is going to be the key skill required to be surviving and be very, very successful in 2021 and obviously 2020. So the ability to look at the larger picture, digitally transform companies, and the ability to give end-to-end solutions by understanding the business change is going to be very critical. All right. So I'm not going to take a lot of time. I'm not going to talk a lot about Globant. Also, I think we will send across some offline content for you to view. Just that basically we are very proud to be in this space of transformation. We are the foremost. We are in the leadership quadrant of this space. Not money have been able to reach at this space. We are growing very fast. We would like all of you to join us at some point. But like I said, look at it. What is very critical for you today at this juncture is this ability to understand what you're working on. Wherever you're working on, whatever you're working on, focus on transformation, focus on what you're going to create. That is going to be the key from here on. All right. So let me quickly stop this. I'll quickly go through a video so that I don't bore you any further, and then I'll hand over to the good stuff with Gaurav. All right. Just a second. All right, take you through this very quickly and then we can go on.
From time to time, we need to reinvent ourselves. We're always growing, changing, as people and as brands. At Globant, we go beyond our peers. We are reinventing the professional services industry. Millions of people are impacted by the solutions we create. With products built by blending engineering, design, and innovation at scale. With our studios, deep pockets of expertise focused on the latest technologies and trends. Our reinvention starts with each of our Globers, over 10,000 around the world. Our global team is multi-talented, multicultural, and extremely passionate. We rely on autonomy and organize ourselves into agile pods to drive speed and quality for our customers. We provide transformation that goes beyond digital. We embrace the power of artificial intelligence to augment Globant's capabilities. With the help of AI, we are revolutionizing the way we recruit and retain our talent. The way we code and design. It's a matter of following a vision, a dream. We are reinventing digital so you can reinvent your business. Globant, we are ready.
All right, that's it from my side. Over to you, Anaga.
Yeah, thank you so much, Shiv. That was an awesome, awesome explanation about what we should be looking at and what's coming and how we should do a digital transformation. So now I want to take up, give it out to Gaurav. Just a few guidelines, team, before I want to hand it over to Gaurav. So Gaurav Mahajan, he is the head of the automation practice at Content Surf, and he's going to be taking and talking about the next topic, which is how to use, automation as, so basically using machine learning in the new age of automation testing. And like rightly so, this is in line what Globant has, where we are looking at using AI in any of our practice areas and even giving any of our digital solutions and transformations that are happening, right? The couple of guidelines that I want you all to follow is we will be taking up your question and answers during the session, but you need to type it. So as and when any questions pop up, feel free to type it, but the answers, Gaurav will go ahead and take it up at the end of the session. Also, there's a small polling session which we want to take, which we would like you all to take it up at the end of the session. So please follow these guidelines, and so that we assume that it's going to be a good transition and a good session for you. So Gaurav, over to you.
Thank you, Anaga. Thank you so much, and thank you, Shivraj, for setting up the context so much in the relevant of current times. Good morning to all of you. It's overwhelming to see 243 people logging in on a weekend, early morning. So kudos to all of you who have managed to come this far, and I will try my best to basically give you a good idea. So after basically, this conference is over, my intent is that you have a very good idea about what machine learning is, what kind of value it is adding to test automation, what kind of dent it is making. And I'll try to keep it very simple so that people who have understanding of machine learning and people who do not really understand what machine learning is, they both can equally gain perspective from this. My name is Gaurav Mahajan. I work for QuaNTA in Pune. I have been doing automation for my bread and butter from past decade almost. I would take you through this presentation. So let me just start, sharing my screen so that we have. Just bear with me for a minute. Yeah. So I hope you all can see my screen. So yes, we are going to talk about, how can we use machine learning in this new age of automation, test automation. We already know that what test automation is all about, most of us. And we keep on hearing about AI, machine learning, deep learning. So what are these things and how they are basically going about creating any value? But before we actually dwell into it, I would really like to thank Globant for giving this opportunity to participate in this premium web conference. What you see on the screen right now is their lovely office. I was there last year. Unfortunately, due to COVID, we're having this online. But thank you so much for pulling me in and sharing my thoughts and a little bit of experience which I have around this. And before we actually, kind of get started with this, I'll also try to give you that, what are we exactly going to talk about today? I think it would be a good structure to follow that. I first of all start with what exactly is artificial intelligence. We keep on hearing, as I said, about machine learning, deep learning, neural networks. What are they all about? And what, why, and how basically machine learning is is creating value, and then how it is basically creating a dent in software quality landscape, and how it is impacting test automation and software quality on a whole, not only test automation but software quality on a whole, and what kind of problems basically we can target to solve using machine learning. And then my perspective of that machines are coming for sure. I mean, we have been talking about it. A lot of people ask these questions, and I get to, I get to ask this question to a lot of people that, what do you think AI will replace human efforts? And how people kind of ask me this question very often, that can test automation be 100%? So similarly, we'll touch base on those areas as well, that how exactly they are working and what kind of coverage we can expect out of them. So before we actually get started, and before we actually start talking about artificial intelligence, all of you must be having a hand raise option in your chat box. And I want to quickly squeeze in a simple question. How many of us can claim here that they have a fair basic understanding of what AI and machine learning is? you can just quickly, click on the raise hand option, and I think that will just give me some understanding of, how many people actually are kind of well versed, or they have like a basic understanding. They have a very clear idea about what is AI and what is ML. Okay. Any responses, guys? Can you help me with any of the responses if you?
Yeah, the number is going up. It's
Okay.
there's still a couple of people raising their hands.
Okay. Okay. All right. So it's fine even if you think that AI and ML is something which you are not very sure what it is all about. We will touch base on that, and even if you fairly understand what is AI and ML, my first few slides are essentially going to talk about it so that we set the context right for in the interest of the larger audience. So first thing first, AI is not something which has cropped up in last few years. AI has been around from last 7 decades, to be honest. And Alan Turing, who is basically called as father of computer science, was the basic guy who could envision that you can teach something to the machines and machine can understand that, and machine can learn it if you teach them properly. Just interesting trivia that if any of us have kind of seen watched this movie called The Imitation Game. It's on the life of Alan Turing, which basically essentially talks about that how his work in decoding Nazi Morse code in World War II was a game changer for the Allies, and how it basically went on to become the foundation for supercomputers later on. It's on Netflix. You can watch it. But Alan Turing's concept were the early inception points for artificial intelligence, and artificial intelligence was, prompted nothing as basically ability for machine to mimic human action, right? So it's a very vague and broad term. So even if a machine can perform any of the human action, a singular human action, it basically falls under artificial intelligence. Then somewhere in 1980s, we started talking about machine learning. And what was machine learning is that doing human action, but having a bit of variety and having a bit of logic attached to it, having a little more depth on those actions, having a little bit of intelligence, ability to kind of handle more cases. I'll come to the example of it to make it a little more clear. And of course, deep learning is post 2010, where machine can automatically understand. I mean, it doesn't really wait for an external data source to provide that data set or a training material. The machine themselves are capable of making observations and enriching their knowledge base. So we'll come to that, as I said. But having said that, in 2019 itself, about 70% of the companies are working to basically implement AI in some way or the other. In pre-COVID era, it was estimated that by this year, AI will create 2.3 million new jobs and eliminate 1.8 million of them. There are so many businesses, Swiggy support, Zomato support, Uber support, where they are deploying AI for customer interactions and grievances, addressing issues, to provide solutions, making reactive decisions, so that the end customer experiences or the support issues can be dealt with without having a human intervention in place. And I personally feel that if you see AI and you club it up with predictive analysis, RPA, IoT, this will basically going to change the world we are living in. And there are so many a number of use cases. I mean, this session is not going to be enough to talk about it, but there is so much of excitement around it, and I'll come to those use cases as well. So, as I said, artificial intelligence is a larger set, is a superset where you can say a technique which enables machines to mimic human behavior. Anything under that umbrella is artificial intelligence. Machine learning, however, is a subset which uses some statistics and statistical methods to enable machines to improve and with experience in terms of providing more training data. And deep learning is a further subset of machine learning, which basically is capable of thinking like human with the help of neural networks. There can be multiple layers of neural networks. So what we are going to focus today about is not artificial intelligence on a whole. We are going to specifically focus more on the machine learning, because that is what is creating an impact on software quality assurance and test automation piece. So now that we have some context to this conversation, my next 2-3 slides are going to deep dive more into the machine learning piece. So having said that, we vaguely kind of understand and we see things around which are basically coming from an AI engine in the background, but we kind of sometimes fail to kind of understand that it is AI, and and sometimes we are able to recognize it. We all must have seen the Boston Dynamics dogs and the robots, basically the robo dogs, where in hardware and a software both are involved, and that's an artificially intelligent system, right? We as I said, we have the chat responses from Swiggy to kind of looking for a refund for a bad delivery. That is also AI in most of our cases. Similar is the case with Uber. There are certain policies that if you have cancelled your cab and within 5 minutes of booking it, your money will get deducted and will come back, right? I mean, so there is an AI in place which basically takes that decision, and based on the policy and based on the condition of the interaction. So basically, AI is something which, as I said, which can analyze data. It can recognize speeches as well, and as well as images. It can make decisions. It can solve problems, right? So AI, if you see this image over here, AI is basically is in a broader technical terms, it's ability to sense or reason or engage or learn, right, of any software or software or hardware combination. Voice recognition, computer vision, robotics, as I said, planning optimization, knowledge capture, computer vision, such some example of under this umbrella. Machine learning, however, is to learn something. Now, there are different models under machine learning, which are supervised learning, unsupervised learning, and reinforcement learning. And I'm going to cover this in next couple of slides as well. And what they bring out as as a result is the ability to reason. They can classify things, they can make decisions, they can do some regression as a not regression testing, but they can give you a broad level of results, a broad range of results, and says that this is what it is all about. This is the range. These are all possible combinations. Those kind of things. And there are a lot of technology platforms through which you can enable AI, and it's not only, of course, software testing, but or test automation. You can use it by sensor. Your biometrics in your office is also sort of AI, right? So it basically, and when you buy a new phone and you set your fingerprint for unlocking it, it asks for different samples like 8 to 9 times, and that is also AI. That is also basically, it's learning. It's ML basically. Not even AI. I mean, to be specific, it's machine learning. The machine is learning and setting its knowledge base for all possible combinations of your face or your fingerprint, and based on that, it will be able to recognize you, and it will be able to grant you access to the device, right? So these are the abilities, some of the abilities of artificial intelligence system. Having said that, as I said, that we will be specifically talking about machine learning for some time, and then we dwell into the use cases which are making impact. So pay some attention over here at this section. Of course, as I said, that machine learning is about teaching computers how to learn data and store that data, and based on the analysis on that data, they are able to make some decisions. So machine learning doesn't ask an engineer to program itself. It asks for patterns. So traditional programming is all about providing an external program, writing a program, providing data, and then there is an output which basically comes into the picture. So I'm trying to basically highlight this. Okay, and while machine learning, on the other hand, is something where you do not provide the program explicitly, you actually provide the output information. What is the kind of output you're looking for? You provide the data, and you say to the machine that, see, this is what my data is, this is what I'm expecting out of it. You sort this data out, you program yourself as per your liking, and you kind of tell me that if it is right or no, or you do this for me. So you provide the output and you provide the data, and the machine learning provides and builds the programs around it, right? So how do they do that? So machine learning, and now I think we all you can pay a little bit of attention here that machine learning, or any sort of learning, is actually three types, and I'll break it down for some simpler terms, for you. We all are working in this industry, and we all must be remembering our first day of our jobs, or first day of our school. Maybe we were too young to remember that, or first day of our college, maybe. So whenever a kid or anybody who starts learning something, there are some basics which are taught to that person. When a kid hits the school, we starts with alphabets, and then we comes to words, and then sentence and grammar and other nuances. When we go to a workplace, for example, for a software tester, we are taught maybe what is a test case, what is software testing, what is defect, what are test cases, test management systems, automation, very basic stuff. The expectation from that person is that they understand what is being given to them, and they perform action accordingly. This is, in a way, is supervised learning. I mean, you're supervising that person. You're not giving autonomy to that person to make decisions. You are saying that, see, this is the data, this is what I want you to understand, and this is what I want you to do. This is supervised learning, right? You provide information as much as you can. You provide structured information, and then you let that person work based on that information. This is supervised learning. But once the person gets 2 years old or 3 years old in the system, and you give, and let's say it's a senior engineer, to a senior engineer, you say, see, you have to take care of this module. You have to take care of the user stories which are coming in this release for this module. So you decide the test strategy for this. You decide what kind of testing techniques you're going to use to test this feature. And you can also decide that at what level you want to test it. You want to do it on regression, you want to do it on functional, you want to cover something on the unit basis as well. So this is unsupervised, where you are giving instructions, but you are allowing that person to make decisions based on their cognitive intelligence. But in case of machine, Unsupervised learning basically is, of course, based on the previous experience the machine must have gone through, right? And similarly, in terms of human also it is true. So the complexity is with with the executor, or you can say with the agent, or with the human from whom we are expecting complex decision making. So having said that, coming to the reinforced piece, very simple, very I can say in layman terms, if you have to teach something to a non-human entity, let's say your pet, your cat, or your dog, or any animal, what is the best way of teaching something to them is developing a reward system, right? So if they do what you expect them to do, you reward them, and if they don't do it, you punish them. So they understand, they reinforce this thought that, okay, if I do this A, B, C, these are the set which will tell me that, okay, I'm eligible for a cookie or a candy or treat, and if I do this, I will be disciplined, right? Kids are also disciplined. We all have been reinforced, right, by our parents at some point of time. So now, if I have given you a basic idea of what it is all about, I will also just try to point out what kind of problems supervised learning can solve. So it can provide regressions. It can provide predictions, weather forecasting, market forecasting, population classifications. Means it can classify things. It can tell you that, okay, these are your symptoms, maybe this is the disease, right? This is one of the very critical use cases, my favorite use case. I've worked on it. It can basically capture a lot of data and then can tell you that this is what it is. So for example, Google kept on collecting image data for a lot of time, like for years, right? And at some point they came up with this Google Lens. Now Google Lens has this huge plethora of humongous database of images in the background, on which it is already supervised, and it is learned through the supervision or through supervised learning that this image which I'm seeing or which I'm capturing is basically this. Right now they are correlating that use case with Google Maps. So now Google Maps, I mean, in last Google I/O, Sundar Pichai showed that use case that with Google Maps, if you're standing somewhere and if you point your camera to a restaurant, it basically tells you the Google rating of it, and it tells you which restaurant that is, right? So they are basically using all that data which they have gained for years, and now they are just using a simple layer of machine learning on top of it, and coming up with all these stunning use cases, and we use it and we're like, wow. But having said that, a little more clarity on supervised and unsupervised learning with an example. Okay. So please, okay, let me just quickly, I'm so sorry. Let me just, yeah. Okay, so let's take an example of supervised learning, and I think you all can relate to this. This is very similar to how Google Lens works actually, or any image recognition works basically. So there is an AI system, basically a machine learning system. You are providing images of cat, different breeds of cat, different size and forms. But you are telling the machine that these are cats, these are cats, these are cats. So the machine is learning that what variety of cat images are possible. There can be different breeds, they can have different facial structure, they can have different shape and size. And at the same time, uh, it is storing that information. So when you start providing images of which is not a cat, let's say of an elephant, tiger, dog, or anything like that, it basically has intelligence to discriminate between what is cat and what is not a cat. So it says it might be a dog, tiger, I don't care, but I care about what is a cat. So I can explicitly call out what is a cat. I have that intelligence. So this is the outcome of supervised learning. So as I said, it can sort things to an extent. It can sort out cats from a number of animal images. It can identify real values, right? It can identify explicitly that, okay, I know all the breeds of cat. I can, any shape or form, I'll be able to figure it out. This is supervised learning. We are providing the label along with the data. We are providing the desired output with the data, and that's how it is working out. In unsupervised learning, it is not the case. In unsupervised learning, it is a little more refined and it is a little more conditional. So if you provide all the data set to the machines and you provide elephant, dogs, cats, everything, and you let machine decide which are the images which are probably belonging to a group. Somebody, all the images of this kind where we have, whiskers, we have, very predominant whiskers and ears on the top, smaller ears, must be cat. If I have to sort apple and banana, I'll in unsupervised learning, I'll try to see red, this size, apple shaped, oval sorts. Banana is, longer, yellow. There is a definitive distinction between the shape, and I'll try to basically at least sort them into two different groups. So I would, and I'll say these are things which are looking similar. So this is one similar group, and these are the things which are looking similar. So this is one similar group. So what it does is it observes, and based on the statistical capabilities and probabilities, it tries to drive correlation in a similar way how a human would, and it basically takes decision on its observation, and it says that, okay, this looks similar, this might sit together in one category, and this is unfamiliar, this might be a different category altogether. So what kind of problems it can solve? It can solve clustering and identifying, maybe not providing a label to them, maybe not identifying, but at least clustering them out. Not saying that this is cat or this is a dog, but saying this is similar, this is similar, this is a similar group. It can do anomaly detection. Wonderful use case, I'll come to that. Anomaly detection is basically where it looks or scans through a series of events, or you can say, a series of interrelated events, and predicts what can be a possible outcome, or is it going in the right direction or not. Superb stuff it can do. So having said that, I have told you about supervised and unsupervised learnings example. The next slide I'm going to talk about reinforced learning. So I gave you this example about training a dog or training any pet or animal. So what exactly you do is reinforcement learning is referred to as an agent. So let's say dog is an agent here. Dog receives a reward or penalty based on the action it takes and the observation it makes. But dog is a living being. Dog is having a mind and legs and body to take action on. But when you talk about machine, there can be a different deal in terms of having a software and a hardware. So if you're mimicking a dog, you have to have a separate hardware, and then you have to have a software. So basically, if you're creating, like, look at the example of Boston Dynamics, like the dogs, which they have created, right? So there is a hardware set, which is an agent, and there is an interpreter. There is the interpreter is through camera is kind of interpreting things. It's having a machine learning inside it, the code inside it, and which is basically then processing it and directing the hardware to take actions. So in this example, there is one agent, but in this example, there is a little bit of difference between agent and interpreter. So there is a policy which is developed with this dog saying that, see, this is the stick, I'm going to throw it, you get it back, you'll get an award. If you don't get it back, you'll get a punishment maybe, right? And dog has to make those observations and understand it and then follow up with the appropriate actions. So this is what reinforced learning is. Okay, so the interpreter and the agent work on the state. Of course, the interpreter has to understand that yes, it's a reward and it's the right thing which they have done, and they also have to define state to basically trigger the response in hardware, right? So that's how it looks like on a broader level in machine learning. All right, so now let's address the elephant in the room. After so much of background and setting up the context, and after maybe almost an hour in this lovely web conference, now let's try to see that how ML can create a dent in software quality landscape, or not only test automation, as I said, the whole software quality for that matter. So before I do that, I hope everyone is with me. Everyone is able to hear me out, right? Hello.
Gaurav, we're good.
Okay, all right, cool. I was just doing a pulse check. Okay, thanks.
Yeah.
Okay, so please pay attention. And it's an interesting slide coming up. Hypothetical question. What do you think that what makes a quality engineer or a software tester as a great engineer? A lot of things. Ability to automate, ability to test, ability to execute, ability to talk to stakeholders and decide things on the go, risk assessment, root cause analysis. The list is endless. This is what my list is. I think this is as close as you can get. A test engineer, good test engineer, knows time management, test design, test approach, coaching and mentoring, defect management. He's logical. He's rational with his thoughts. He doesn't he doesn't shy away from doing risk management. And all the related activities around it. And when we talk about test automation, what test automation does is test automation just takes away the execution of test off from test engineers' table or plate. It basically takes out the manual testing or the valid check which the test engineer had to make in the past. So these are the few things which test automation basically impacts or solves in a complete or a partial manner. It can take off regression testing efforts. It can do some exploratory testing, like to an extent. Testing to security testing can be automated, and automation testing itself. I mean, writing the code, not writing the code, but automation testing as a responsibility is solved by the automation tests process. Monitoring progress, DevOps can help you that, when Jenkins and all those things can help you. Bug reproduction to an extent, that whatever has been failed in TestNG, you can see in the folder, what are the failed tests, and you can rerun them and stuff like that. So these are the few things. You can see that if a good test engineer has to have all these things, then these are things which are addressed by test automation. These are the things which can be addressed by machine learning. Deciding on test techniques, triaging, root cause analysis, deciding that a bug is of what severity and priority, defect reporting, deciding on a test approach. These are the things which can be, and there are other things as well. I mean, if you think about it, machine learning doesn't hold, it doesn't have like a scope. If you're able to capture data and provide it, machine learning will do it for you. So there might be so many other things which I have not pointed out, but there might be things which can be done through machine learning. You know, what I'm trying to say is, looking at this mind map, there were things which were already taken care of by test automation. Now, along with machine learning, you can eat up to so many things and so many responsibility of a human test engineer. So definitely machines are coming, and I cannot be more clear or blunt that with progress we will see, with going forward, we will see that today we wait for Selenium or any open source. I mean, if you're using any open source test automation systems or frameworks and tools, that we wait for their releases and stuff. But going forward, we might just have systems which will just ask for data from a standard system like Jira and do a severity priority identification mechanism for you based on your historic data of bugs. And I will show you that example as well. There might be systems which are using ML are developed in such a way, and of course there are, like, Testcraft, Mabel. These are some of the tools which are already using AI, and they are providing self-healing tests. Self-healing is also a use case which I'm going to talk about. So the point I'm trying to make is that these are certain things which can be done, and I will show some of the examples in upcoming slide that how they can be done. So I wanted to point out certain certain use cases which I'm going to talk about. So I think self-healing automation, defect triaging, defect prediction, test planning, test case management, root cause analysis are certain things which can be addressed through machine learning. Okay. Having said that, let's take a moment of looking at this use case. Looks like this is an automated use case. The property of the objects were tweaked beyond original configuration. So what will happen is, basically, this script was looking for username, and if there was user ID, it will fail. If there is a username, it will work, work pass. This is a typical scenario. A lot of folks in this conference who are dealing with Selenium or any other UI, testing tools, who work on the IDs on the pages, they understand what I'm talking about. So the property of the whenever the property of the the original configurations or the original object was kind of tweaked, the automation script fails. A self-healing automation solution, on the other hand, basically, when it senses that it's not able to find what it is looking for, it looks for an alternative to that. And it can basically develop that understanding based on the studies of attributes of that object, or attributes or properties, and then devising a system that, okay, I have not been able to find this, and looks like I'm not moving forward with the script. What could be the next possible or the next best combination of ID or hook which I can use, which can assert that this case is passing or no? So basically, to take a step back and give you a little perspective on this, if somebody has attended Selenium conference for 2020, this was one of the topics which is covered there. Selenium might want to come with this kind of feature going forward, but I think there is a long way to go about it. As I said, there are certain tools like Mabel, Testcraft, TestIM, I guess, who are already using, and they're selling it as a feature, saying that our cases, our tool basically does self-healing to the scripts. But basically, it works on a scoring system. It based on the previous data or the historical data. It basically provides a probability that what could be the next best naming convention, or something which is out there in the DOM, and it uses some ML libraries. And of course, like Selenium itself is a library, and it has the capability to integrate with other libraries. So ML libraries are also available, which you can integrate and work on this, and this use case is possible, right? So I'm not going to basically give you which libraries and whatnot, but I'm going to basically tell you that this is possible. If you go back after this conversation, this session, and try to figure it out, you'll get it. Giving you an example of a tool who has actually done it. Okay, so for example, of course, if an XPath locator is working fine, then you don't need a full XPath locator. Of course, if the XPath locator is failing, then it is looking for an alternative. If you see, let me just, okay, it is already highlighted, but if you see this piece, right? It is saying that this is the level 0 attribute is ID, expected was this, and actual is this. And the match is 98.87%. So the healing notification is indicating that an element is found with certain confidence, let's say anything between 0 to 100. And you can find the difference between the new encountered element and the old element which is sitting in your script. And this works on certain things where if n equals to 0 means the element in DOM tree, 1 means immediate ancestor of the element, and level increases until the DOM tree root is reached. So in, for example, PHP sort of applications where you have different iframes to traverse, you can use this. This is a very useful information in that case, I guess. So A is attribute name, and just give me a second. Yeah, and V1 is the expected, or you can say whatever you have put in your script or recorded, and V2 is the actual, which is there right now. So just trying to give you a small example of how it is actually working, right? I mean, it would be too short of a notice for me to kind of give you a walkthrough of how it can be developed, and that would require a different session altogether. But this is a use case, and this is how it looks like. Okay. Having said that, another example which I want to talk about is basically how ML can. Just give me a second, guys. I think I just want to switch on my my fan. Just give me. Okay. All right. Okay. So one example of triaging, as in deciding which bugs to fix and which bugs we should not fix, and completely devising this mechanism based on severity and priority. Of course, we know severity is how bad it is, and priority is how soon we want to fix it, right? I mean, this is the basic information which we have been providing with bugs even from non-automation era. So if we devise some logic, a little more logic about severity and priority, right? It makes a life a lot easier. So many times, testers sit and talk to developers saying, no, this should be fixed. And they're like, no, I cannot fix it right away. No, user cannot, progress, or it would hamper the user experience and stuff like that. What if we could solve that problem once and for all using machine learning? I'm giving you the logic of how it can be done. Very simple, that you devise the severity and priority into maybe two axes. One is impact. Impact means if the user bumps into this issue, how bad it would be. 5 being that it would be a showstopper, and 1 being it would be minimal. And probability is that how what is the likelihood, what are the chances, what are the odds that user will bump into this. So if there is a problem on landing page and it's it is something 100% of the users will come on landing page most of the times. So it is bad. I mean, it is very high, and the probability is 100%. And if it is on some setting page in the background and that is outdated and old UI, nobody goes there, maybe very low. So what we are trying to do is we are trying to calculate a value based on this scoring system, and we are saying that anything which is very high in probability and very high in impact, that should that should not be left alone. Something like this. Anything which is high, medium, or low, but is having a very high probability should not be left alone. Anything which is very high, medium, low on impact, but even not like 0% probability, but it is at least having 20% to 100% probability, should not be left alone. And there are other use cases. These are must fix for me. These are not right away, these are later. Okay, so the point I'm trying to make is this is what my this is what my logic is, or I can say the scoring system is. So once I have given the scoring system, I can then provide probably the data from Jira or any of the bug tracking tool. It can apply this scoring on the defects historical data. Historical data of defects based on the kind of severity and priority you have used in the past, or impact or probability you have used in the past. And then it can use that information every time you will provide this information on a new bug. And that will solve the problem of triaging. So you're done basically testing stuff. Your system tells you what are the bugs which needs to be fixed and what are the bugs which doesn't need a fix. But of course, the data has to be accurate. The data of probability and impact has to be accurate. I mean, without that, the system will not predict, will not make the right predictions, of course. So another example which I wanted to give you, apart from self-healing test, is triage. Now, very heavy on statistics, but stay with me on this. This is a very, very interesting concept, and if you get it, you'll love it. And this is, again, I'm talking about logic, that what it can feed into machine learning system and how it can do wonders. It is about, it looks heavy. Of course, I'm taking a reference from a white paper which is submitted. I have given the link of it. Please make a note of it. In the right bottom of the screen, you can see that ripublication.com. This is done by a team in Tamil Nadu. It's nothing but an elaboration of Bayesian algorithm. And what is Bayesian algorithm? I'll come to that. So what Bayesian algorithm actually is basically, this. It says that, this is a defect prediction model, and I'm going to talk about some statistics here, nothing fancy, but if you can put it into your ML system with historic data of your defects. Your ML is capable of predicting defects. Sounds exciting. It is very simple. Just pay attention. So a Bayesian model is nothing but which says that what is the probability of an event when of an event happening when there is a correlated event has already happened. So what is the probability of A and B? And it basically works on probability, numbers, and that mathematics. It says that A and B is a conditional probability, and there is a likelihood of event A given that B has already happened or B is true. Okay. It also says that there is a conditional probability that likelihood of B happening when A is true, and of course, probability of A and B independent of each other. Now, what they were trying to do is they were trying to formulate this in such a way, saying that in what implementation phase or in what phase of software development cycle, what severity of issues we can get. So now I have told you about this logic. Please pay attention to this. This list. What they have done is they have taken requirement defects and they have categorized a possible value. Like they've given a label that if it's an ambiguous sort of requirement, if it's an ambiguous sort of requirement, call it R1, and missing requirement R4. And if it's a design defect, there is a message error D8. If an ambiguous design, then you call it D1. And if it's a computational error, I mean, it's a code problem or a unit testing issue, then you call it CU1, and so on and so forth. And if it's an implementation error, that means it's a deployment problem, configuration issue, you call it DE. And what are the different phases? Your phases, requirement, design, coding, implementation, the typical SDLC phases. And then after that, you also kind of capture the value of the phase in which it is detected. So it might be a requirement issue, but it was found in implementation, right? So it is a miss. So of course they look for phase attributed and phase detected. Okay. So I hope everybody is with me on this. So after these classifications, what they have done is they were having a data of 115 bugs. So first of all, what they did is they kind of figured out a probability of a major, moderate, and minor bug happening in this data out of 115 bugs. So there were 52 bugs. There were 52 bugs of priority, severity major, and 31 and 32 of moderate and minor. So they devised a simple probability saying that 52 divided by 115. This is the probability of a major, moderate, or minor bug happening overall out of this 115 bugs. And then they started tagging every bug, that what kind of bug it was based on this list, this index. It was an R1 kind of bug. That means it was an ambiguous requirement. In which phase it was detected? It was in PD1. So when we say PD1, it was in requirement phase. So it was detected pretty early. And in which phase it was attributed? It was attributed to be in requirement phase only. So the impact of it was very less. So the weight, they have given one weight to it. So saying 1. And the severity then, it is minor, because it is caught in the same phase where it was supposed to, and it was a requirement issue, and it was just an ambiguous requirement issue. So it was a minor issue. Similarly, they went on to tag this for all 115 bugs. So if there was, let's say there was a missing design which was caught in implementation, and because it was caught late, the weight was more and the impact was also more, right? And based on that, what they did is, then using this formula, they could figure out these values, that if there is an R1 sort of defect of severity minor, what are the probability that we'll get into it? If an R1 sort of defect with major severity, what are the probability of having this kind of issue based on the historical data? You put this information in machine learning. Your machine learning will say, boss, you have 50,000 defects till date of your application, and this is what your trend looks like. And this is what my predictive analysis says. You can further refine it using predictive analysis and stuff like that. That's a different thing. But we were doing defect densities in the past, and we were doing this, these kind of statistics were used in software testing any which ways, in the past. But now machine learning can do it runtime. You don't have to look for data. You don't have to worry for problems in the data. You don't have to normalize data. You don't have to clean it up. You don't have to juggle with CSV and Excel sheets. Machine learning will do it for you, and it will use that statistic information and provide an estimation to you that are you doing good or are you doing bad. So this is one example which I wanted to give. Let me just. So I have spoken.
Gaurav, just a quick time check.
Okay, sure. Yeah. So. All right, so I'm done actually, talking the most important parts, to be honest. I'll just give you one more example, and then we will come quickly on the ML overall piece. So apart from the self-healing tests, apart from the priority and severity and triaging piece, and the example which I've spoken about, the defect prediction piece, ML can also provide root cause analysis, giving, of course, an idea to you so that you understand how it works, and then you go about figuring out the complexities later. Saying that, of course, to provide, to perform a root cause analysis, we need to basically detect, what has gone wrong. And this is what I was talking about from the anomaly piece. It can be done through unsupervised learning. If you have all that data where, the root cause analysis data of all the things which have gone bad on production till date, you can figure out through unsupervised learning that what are the patterns and anomalies. And if there is a problem, then what can be a possible outreach of that problem, impact of that problem. And if something has gone wrong, then what can be a possible root cause. So from A to backwards, and from root cause to failure, and from failure to root cause, both the things can be figured out. Okay. Having said that, I wanted to just, this is another important piece I want to touch base on that. So what are the tools? What are the how we can go about it? What is the tool set I need, skill set I need to basically develop these systems on ML? TensorFlow is from Google, basically is a sort of library, you can say, the template, the right template to get started with. Basically, it is a sort of free open source, library which helps you to equip yourself with right mathematics, right sort of functions, statistics to define a learning flow for any simple machine learning, or a complex machine learning program. RapidMiner is a software platform, which is developed to basically, it helps for data preparation and machine learning, as well as for deep learning and text mining and predictive analysis. And it also helps you with sentiment analysis. So what sentiment analysis is, for example, I can run a report on Twitter that based on an unfortunate event, what is the overall sentiment of the people? Or on any event, if the IPL is going on, are people enjoying it or no? Or based on the kind of words they're using in their tweets, I can run a sentiment analysis. So I can understand that if there is a positive effect of that event or a negative effect. Kinaim is again an open source data analytics and reporting platform which helps. And of course, above all this, Python. Python is your go-to general purpose programming languages. Python will do your job. You need to understand Python. There is no way out apart from Python if you want to get into ML. So, and it is easy to understand, to be honest. And of course, a lot of people were using R, a programming language, which was basically developed for statistical computing, and and a little bit of image recognition around it and stuff like that. So these are the things which you can go back and learn about. Now, to further emphasize what I've spoken about. So there are different levels of in software testing, right? I mean, in test automation, the level 0 is where there is no automation. Let's say no test automation, zero test automation. You can see that, probably writing scripts or you can say a very start way of writing test scripts or test data might take this much amount of time. Level 2 is basically there are certain script-based assertions and there are human validations as well. Level 3 is where it is a little more refined and defined. You have greater coverage of automation, maybe 80% or 70% of things are automated. Your test parameters in place, your API tests are there, unit testing is happening, and then you have level 4 where the AI generates some test cases. There is a little bit of ML is in place, and level 5 is the nirvana stage where the AI generates and executes validations. I mean, just look at the number of tests with a matured AI system we can achieve per second or per hour. Staggering amount, industrial amount. I mean, industrial number. So it's like what we were doing, probably one test case an hour, we are able to, or one use case an hour, we are able to do about 5,000 of them in an hour, right? So exponential growth. The spike is enormous. So test automation with ML is going to disrupt. That thing is for sure. Machines are coming for sure. We need to understand, as Shivraj said, we need to understand how the world is functioning and in what direction are we going, right? In what direction the business is going. So not only software test automation, healthcare, finance, manufacturing, retail, e-commerce, ML is everywhere. I was working for a firm where we were developing this healthcare patient diagnostic, where patient used to tell the user, I mean, to the software that what is wrong with it, like, मुझे बुखार है and मुझे ये problem हो रहा है, मुझको, I'm getting, I'm showing symptoms of cough, cold, and throat infection, and I'm showing symptoms of so and so. How many of us have seen those kind of apps, right? This COVID detection apps, which says that you are showing symptoms of COVID. Why don't you get yourself tested? Arogya Setu does that. Simple machine learning. It basically captures the input from you and says that are you having those symptoms which are against the list. So I was working on something like this where the patient used to come in and they used to, there was a speech to text functionality where they used to click on mic button. They used to start telling the problems of what they're experiencing, just like they will tell it to a doctor. And it used to capture all that speech, converts it into text, and looks for the symptoms in the text, that throat pain, cough, cold, fever, and it says maybe maybe your symptoms are like this. You might be having this problem. You're having abdominal pain, then this might be your problem. So we are moving towards that sooner than we all think. So definitely you will see all these things happening around you, or they are happening around you right now also. And you have probably not paid much attention. But as I said, it is easier said than done. Any half-cooked implementations are cringeworthy, and it is hilarious, to be honest. For example, this example of Indigo, like for example, they have a layer of machine learning for their social media. So it keeps on checking that anybody who is tagging them or calling them on Twitter and saying certain words like thank you or using positive words like brilliant, good, satisfied, good job, they automatically think that it's a praise. Now look at this example. This guy is like, thank you for sending my baggage to Hyderabad and flying me to Calcutta. This is a sarcastic address. But machine learning is not powerful enough here because it's half cooked. It is not getting the message. It is not correlating that the baggage and the person has gone into two different directions. And it says, okay, glad to hear that. Thank you so much. Keep flying with us. Right? Look at this on the left. It says that how would you describe the term bot to your grandma? And he says, my grandma is dead. And he's like, thank you for your feedback. I mean, the absence of cognitive intelligence cannot compensate certain such use cases. So any ML systems which are in development and they are not robust, then they will create they can create more trouble than creating wows. So it is also necessary that when you are going about developing ML systems, training them, you have ample amount of data, and you have done your research, and you have ensured that what kind of problems you might face into, what kind of use cases it might bump into while having a user interaction or a human interaction, right? So having said that, that's all about it. I think that's what I had to say. I rest my case. This is my LinkedIn account link. If you want, you can reach out to me. You can write into me on my email. I am there. I usually check my LinkedIn. We'll be happy to hear from you, feedback of this session, and even if you want to have certain questions asked, I'll be happy to take them offline as well. So that's about it. Thank you so much. Anaga, all yours.
Yes, thank you, Gaurav. That was really a wonderful session, because I think we got a lot of insight in not only what is machine learning, but how we are using it for practical purposes, right? So let's quickly switch on to some of the few questions. I have kind of shortlisted a few questions so that we don't spend a lot of time answering them. But one of the popular questions that has come up for almost all of the interested audiences, that, what is the paths that one needs to follow for taking up this machine learning and overall deep learning as a part of their career, and how would you recommend them to get started with that? Gaurav,
Okay.
I think you're on mute.
Yeah, I was on mute, so sorry. Okay, so to be honest, we are living in times when there is information everywhere, to be honest with you, right from Udemy courses. I mean, I'm not endorsing Udemy, but any online courses, to going and figuring out how TensorFlow works. What is ML? Like, I've given you a basic head start. Google is the go-to place. ML is, people are really excited about ML. There is a lot of information about AI. If you really want to understand, there is no scope of it. Like, there are n number of use cases we can address in AI. So if you just want to keep your scope narrow, I would say go and check out the kind of white papers, scholarly articles people have done for how to use AI and machine learning for software testing, and start from there. So that what will happen is you'll start correlating the processes of software testing and test automation with capabilities of AI. And then you start about, once you understand the problem well, then you start attacking that how you're going to solve it. Like, is TensorFlow is going to be the right tool, or any other tool which can help you? And then that's how you can probably circle on a whole use case. So I would say, identify one problem, identify one tool. Online, there are on YouTube, there is a plethora of information. Spend some time, utilize these times for your learning, and that's how I would say you go about it.
Right. So just to even add, in fact, to Gaurav's this, right? Probably there are these sites called Machine Learning Mastery, which I have personally found it to be a good site. You could just even copy paste the code which is available over there, right? Use the file that they have and just go through it to understand what it is doing. Because I think even just in connection with that, right? The next question that was asked is that, how much percentage or how much knowledge does one need to have related to the algorithms, to the statistics, etc., Gaurav? So I know there's a lot, but you can answer that.
Yeah, I would say, don't worry about it. Get started. It's not worrisome, and it is not a prerequisite. If you have gone through your graduation, it's enough. I mean, so I think,
and if you remember,
enough maths, enough maths you have seen. I mean, I was horrible in maths, but I would say probability, statistics, and all these things, these are not difficult to understand.
and then fitting, or then algorithm building comes later. But as Anaga also pointed out, there are so many sites, there are so many people who have done good jobs, and they have published it out for everybody to use. So there is enough of
Absolutely.
information, you know? So
Right.
don't worry about it.
Yeah, there are actually skykits, like Python skykit library, which is available, which has
Yeah.
these models already designed, right? All you need to do is give the data as input, and you'll get to see the results. So even those is good as a starting point. Definitely
Yeah.
you can use that. So moving on to the automation, Gaurav, I mean, will you be able to kind of let the audience know what are the popular, I know we went through it, self-healing, etc. But what are the other different areas which you think, the problems that could be resolved using machine learning?
You mean to say in test automation?
For test automation, yes.
Okay. So to be honest,
We
to
spoke
answer that
about
question,
self-healing, but something more.
yeah. Yeah. So I think anything which can be quantified and you can collect data, that kind of problem can be can be addressed through machine learning. So instead of giving you a particular example, I would say I'll keep this answer very broad. Machine learning is nothing but it allows you to collect data and provide some labels on top of it and giving a structure to the machine, and machine takes care of that problem. So in automation, apart from maintenance, what are the other problems you get into? You might get into problems as in that you were running Selenium Grid, you were running different browser and OS combinations. Your tests were flaky, not because of the maintenance, but they were flaky because when they were running in headless browsers, we were not able to fix them, or they were failing very often. So what is the data you have? How you have fixed those issues in the past? If you have information on how you have fixed those issues in the past, you can quantify it, put it into an ML system. ML system can themselves make your automation test less flaky. And when I say less flaky, it's a very huge prerogative. I mean, it can be in headless browsers, it can be different combinations of browser, it can be on different resolutions and stuff like that. The main problem with UI testing or test automation has been that uh, the flakiness. When I say flakiness, it's like the 10 to 15% they just break because there is a change in ID, or there is a change in resolution, there is a change in hardware, right? And that is why people go on API level or on unit level. They want to replace the UI tests with anything on the lower layer. But ML, if you have same problem, which you're solving again and again, you can call ML for help, you can train the system, and that will recognize the pattern and solve that problem for you. So of course, flaky test is a broader prerogative, but that can be solved.
Right, definitely. I think even that gets answers the question that one of the audience asked, that they have a current existing automation framework which is written in Selenium, and how do we get the test automation Selenium environment to start using the ML? So I think the same thing, that if you identify the problem, you have the data for it, go ahead and start introducing the model to it. Obviously, it's going to be a lot of R&D, but you see that the problem is solved, it can be solved by machine learning, right?
Yeah, I mean,
so
try to get your hands on Selenium Conference 2020. There are engineers who have specifically spoken about it, and try to Google about around that. I think you'll get a lot of stuff. I would rather say that there is enough R&D happening in the background. Selenium might come up with some ML capabilities in the future itself.
Absolutely.
So we just have to watch out.
Right. I think that's it, Gaurav. Pretty much we've answered all the questions. So everyone, the poll has been opened up. Please go ahead and answer your questions related to the poll. I think we'll just wait a couple of minutes, Gaurav, but thank you so much. This was a wonderful session. I mean, I hope to call back in future. In the audience, we have upcoming sessions, couple of more sessions arranged. We'll soon announce the date as to when those sessions and when those web conference series we plan to continue. please be on a lookout for it. It's there on our QuaNTA NXT website. We will be dropping an email. We'll be publishing it also on the LinkedIn and other platforms. You have been a wonderful audience. There have been wonderful questions coming up from us. And I hope we have managed to satisfy at least a good amount of the questions. But if not, please feel to reach out to us or to Gaurav directly, and sure we can help you with that, right?
Yeah.
Thank you so much. So we're just waiting for the poll to finish, and then we are done.
Thank you, Anka. Thank you, everybody.
Thanks. Yeah, thanks, Gaurav. So I think one question, we will be sharing this series on the YouTube. So once be on a lookout for that on